The problem here is from the top of a hill, the angle of depression of two consecutive kilometer stones due east are found to be 30° and 45°. Find the height of the hill. Let us say that this is your hill, okay, and you have 2 kilometer stones. Kilometer stones means what? You've heard about milestones. Milestone means two stones that are placed at 1 mile, 1 mile apart. Normally, when you're traveling on a highway, you see these milestones, okay, at the side. Like say Kolkata, 23 kilometers. That's a milestone. So here you have a milestone, and here also you have a kilometer stone. In fact, not a milestone, but a kilometer stone in this case. And you have an observer at the top of a hill here. Okay, so here is your observer. Okay, and he observed from the top of a hill. The object is here. These two are your objects, right? Object one, object two. So the observer from the top of a hill is observing the first kilometer stone here and the second kilometer stone here. These two are the line of sight. These two are his lines of sight. Okay. He's observing these two stones. And when he's observing these two stones, he's found that his angles of depression of these 2 kilometer stones are 30° and 45°. So angle of depression of these means, what is the angle of depression? From the definition, we know that the angle of depression is the angle that the line of sight makes with the horizontal. You draw a horizontal line here. This is your horizontal. So therefore, now the line of sight of the observer makes an angle of 30° and 45°. 30°, this is the angle of depression of the first kilometer stone. And the next is, obviously, this will be 45° because this is the greater angle. Okay, 30° and 45° respectively. Okay, these two are your angles of depression. Now what you do is you complete this right angle triangle in this way. In this way, okay, you complete this kilometer stone and you complete this kilometer stone, this right angle triangle in fact, and here is your 90° angle. Okay, and this is your hill. The question here is find the height of the hill. Let us say that the height of the hill is x. We name this right angle triangle ABC. Now if this angle is 30°, this angle must also be 30°. These two are parallel, right? This angle is 45°. That means this angle is also 45°, right? Now with the help of these two angles, we are going to find out the height of the hill. Okay. So how do you, what if, and what you see is what should be the difference between this problem and this problem? If you see in this problem, in the first problem for type 1 only, you had to find out this distance, right? You had to find out this distance. This distance was given. This height, in fact, was given. Out here, you have to find out this height, and this distance here is given to you. How is it given to you? These two are kilometer stones. Therefore, they obviously must be 1 kilometer apart. Therefore, this distance is 1 kilometer. Okay. Any question? If not, then we proceed with finding. Okay. So this is, in order to find this, we observe that there are two right angle triangles. First of all, this right angle triangle here, and you have the bigger right angle triangle also, ACB. Okay, so we use these two triangles in order to find out our height. So let's see how to find out our height. So which two triangles I'll consider? So we shall consider the triangles let us call this C, this let's call this point D. Let us consider triangles ADB and ACB. These two triangles. Okay. So considering the first triangle, in triangle ADB, okay, where you see the 45-degree angle, considering that triangle, tan 45. Why are we using tan? Let's see why we use tan. See that this
So because
angle,
perpendicular by base.
yes, because we need to find out this length here. We need to find out this length, and we need to find out this length also, right? And these two sides are related with this angle. How? These two are related with this angle. How? Only by tan. So therefore we use tan. These are this is the perpendicular and this is the base, and therefore these two are related by tan. You have tan 45 degree is equal to AB by BD. Okay. So what I do here is tan 45, is 1. And let us take, we have taken already taken, let us see what is the length of AB. The length of AB I have taken as X. So I write X. Okay. And I say let BD equal to Y. Okay, that is this length I take Y. So therefore, for BD I write Y. So X by Y I get equal to 1. That means I get X is equal to Y. Okay. This is 1. Hey, yeah, whoever that is, if you have the guts, you come in front, okay? If you have the guts, I'll send all the kids of Topsia and then see you. Okay? If you have the guts, you come. सामने आकर के बात करो. X is equal to Y. This is our first equation. We consider the next triangle. In triangle ACB. Now see, I have taken this length as Y. And this length is 1 kilometer. That means what is the length of BC? BC becomes Y plus 1. So BC I write as Y plus 1 kilometers, obviously. And therefore now I consider the bigger triangle ACB. Again I will use tan. Why will I use tan? Because in triangle ACB 30 degree, opposite to 30-degree angle is your this length, and then you have your this as your base, BC. Okay, because we are concerned with this. We are not bothered about the hypotenuse. So therefore, these two are related by tan. So tan 30 degree is equal to AB by BC. And tan 30, the value is 1 by root 3 is equal to AB. The length of AB here is x, and the length of BC here is y plus 1. Okay, that means you have x root 3 is equal to y plus 1. That means x root 3 minus y must be equal to 1. So you're getting two equations here. See, first equation we have got x is equal to y, and this is our second equation. Now we shall solve these two equations simultaneously in order to find out x and y. How do you solve? Put x is equal to y from 1 into. So putting x is equal to y from 1 into. We get put the value of put y is equal to x, leave x as it is. So putting y is equal to x. Okay. Now you can take x common. Get root 3 minus 1 is equal to 1. By root 3 minus 1. Now we shall rationalize the denominator in order to find out the value of x, in order to make it easier to find out the value of x. It's 3 minus 1 if I can write. Any problem if I write 3 minus 1?
So you direct write 2, then also we don't have any problem.
Good. Now you know the value of root 3 to be 1.732, because as I told you in class 9 only, root 3 and root 2 you must remember. 1.732 plus 1 divided by 2. So this is 2.732. So this is 1.366 kilometer. And have they given you till what decimal place to write the answer? No. So 1.366, and you can, if you are, if it is given, round it off to two decimal places. You can write this as 1.37 kilometers rounded to rounded off to two decimal places. Okay. So since nothing is given, 1.366 should be your answer. Okay. So if you see in the type 1, you had the same figure. Here, if you see this figure, and if you see here this figure, they were the same actually. Okay. But the difference is I don't remember solving this problem, but I don't know. This is not here also. Maybe I had started and did not solve. But anyway, just go through this problem. You'll see that the basic difference between this problem, problem number 1 for type 1 and problem number 2 for type 1, is that in the first problem you had to find out this length and this height was given. In this type 1 problem, you had to find out this height where this length was given to you. So that is the basic difference between these two. Now we move on to the type 2 problem, the third problem for type 2. The question here is the angles of depression of two ships A and B as observed from the top of a lighthouse are from top of a lighthouse 60-meter high are 60° and 45° respectively. If two ships are on opposite sides of the lighthouse, find the distance between the two ships. So let's see which one is the lighthouse. Say this one is our lighthouse. Okay. And the angle of depression of two ships as observed from the top of the lighthouse. Angle of depression, and that to observe from the top of the lighthouse. So here is our observer. This is our observer. Okay, he is observing two ships on the opposite sides of the lighthouse. So this is our lighthouse. One ship is here. So this is the object. This observer is observing this ship. This is the line of sight. And another ship is here. This is another line of sight of the same observer. And we join these two. Okay. So this becomes your, this AB actually is your river. It is this AB is your river. Okay. The question is find the distance between the two ships. So this is your ship and this is your ship. So you need to find out the distance between the two ships. That means you will have to find out this distance. Okay. Now let us see what angles are given. The angle of depression are given. The horizontal is AB. In fact, this is also your horizontal. This is also your horizontal. Okay. And the angles of depression are given. So the angle made by the line of sight of the observer with the horizontal, this angle is given to you as 60°, and this angle of depression of this ship is given to be 45°. Okay. And the height of this lighthouse is given to be 60 meters. So let us call this C and let us call this D. So CD is our lighthouse. This is our lighthouse. Fine. Question here is find the distance between the two ships. That means we have to find out the distance AB. Now, how do we find out the distance AB? Before that, before finding out the distance, the first observation that you must make is that if this angle is 60°, this angle must also be 60°. And this angle must also be 60°. Okay. In fact, 45°. And there are two right angle triangles. This is one right angle triangle. This is another right angle triangle. Okay. And in this right angle triangle, the angle that you know are, let's call it, this is 90° angle. The angle that you know are 60° and 45°. Opposite to 60° is your lighthouse, CD. And base becomes your ED, which is the distance between the lighthouse and the ship at A. So which means since you are not bothered with the hypotenuse, so again we are going to use tan in order to find AD because you know CD already. So we have tan 60° is equal to CD by AD. Now tan 60 is root 3, okay, and CD you know as 60. You can find out AD from here. So AD is 60 by root 3, which is, now if you rationalize the denominator, multiply the numerator and denominator by root 3,
20 root 3.
you get simply 20 root 3. So keep it as it is, this much meters. Keep it as it is. We'll come back to this. So we have managed to find out the distance AD. Similarly, using this right angle triangle, we are going to find out the distance BD. So we have tan 45 is equal to, again, perpendicular by hypotenuse CD by BD. Tan 45, is 1. Length of CD, that is the height of the lighthouse, is given to be 60. So you can find out BD. So BD is 60 meters. Okay. So AD, we have found out 20 root 3, and BD, we have found out 60. So therefore, what is the distance between the two? This is 20 root 3 and this is 60. If you add up these two, you will get the distance between the ships. Hence, distance between the ships is equal to AD plus BD. Hence, distance between the ships is equal to AD plus BD. And AD here is 20 root 3. BD here is 60. Okay. So you can take 20 common. You get root 3 plus 3. That means that 20 root 3 is 1.732 plus 3, which is 20 into 4.732. Multiply this, you get 94.64 meters, which when rounded off to the nearest whole number is equal to 95. You round this off to the nearest whole number, because in the question it is given rounded off to the nearest whole number. See here in the question, correct to the nearest whole number. The statement is there. So 94.64 is equal to 95 meters. Correct to the nearest whole number. Okay, that's it. This is for third problem, or the first problem of type 2. Same problem, same figure. We'll discuss the next problem. Same figure will be there, except that in that case, this length will be given to you, this AB. And you will have to find out this height. So let us see how to do this. Okay. Let us proceed to the next problem. Problem 4. Question is, the angle of elevation of a pillar from a point A on the ground is 45 degree, and from a point B diametrically opposite to A. Diametrically opposite to A means exactly on the opposite side of A. Diametrically opposite to A on the other side of the pillar is 60 degree. Find the height of the pillar given that the distance between A and B is 15. So let us draw the pillar first. Okay, this is your pillar. And this is your point A. And B is diametrically opposite to A. Okay. Now, what you do here is from A, the angle of elevation is given of this pillar. Top of the pillar, in fact, they should have mentioned. If it is angle of elevation, it has to be, the object has to be in the at a certain height. So it has to be the top of the pillar. Anyway, so the top of the pillar, this angle of elevation is given to you. And also from point diametrically opposite to B, the angle of elevation is given to you. These two are the line of sight, okay, of the observer at A and B. And this is your horizontal. Okay. So what are the angles here? 45 degree and 60 degree. You can take the other way also. You can take this as 60 degree and this as 45 degree. No problem. It's the same thing. Okay. And the distance between A and B is 15 meters. Okay. Distance between A and B is 15 meters. The question is find the height of the pillar. That means now you have to find out. This is your pillar. You will have to find out the height of this pillar. Let us say that the height of the pillar is h. Okay. Let us call this point T. So I assume let the height of the pillar be h. Let the height of the pillar be h. Therefore, CD is equal to h. Also, I say for simplicity's sake, let us take this as x and this as y. So also let this distance AD equal to x and let us take BD equal to y. Okay. Now we shall find out x and y. In fact, we'll find out h. Now, if we have taken this length AD to be x and BD to be y, what is the first equation that we get? We know that AB is 15 meters. So therefore, x plus y must be equal to 15. This is the first equation that we get. Call this equation number 1. Okay. The next equation that we are going to get will be with the help of these two triangles. You will get one equation with the help of these two triangles. So let us consider this triangle first. That is triangle BCD. We'll again use tan because we are not bothered with hypotenuse. We are only bothered with perpendicular and base. So tan 60 is equal to CD by BD. Okay. Tan 60 is root 3. CD is H and BD is Y. So you get H is equal to root 3 Y. Also, you have tan 45. We consider this right angle triangle now. Tan 45. Tan 45 degree is equal to CD by AD. And you know tan 45 is 1. CD is the pillar whose height is H. AD we have taken as x. So you get h is equal to x. Now see, you're getting h is equal to root 3y, h is equal to x. Let us say call this equation number 2 and let us call this equation number 3. From these two, if h is equal to x, putting from, if I from 3, h is equal to x. From h is equal to x, from 3, if I put in 2, then we can remove h in putting in 2. We get x is equal to root 3y, right? So call this equation number 4. Now you see we have two equations. This equation we have in x and y, and we have this equation in x and y. We can solve these two equations simultaneously in order to get the values of x and y. Once we get the values of x and y, we'll add these two values in order to get the length of AB. Okay, I stop here for today. I'll continue tomorrow.